Alright, now let's take a look at the regulation of glycogen. Insulin and glucagon are two important hormones that regulate the synthesis of glycogen in the fed and fasting states respectively. So let's go over each of these hormones now. Now in the fasting state, the synthesis of glucagon as well as epinephrine are driven by low blood sugar levels. Now both of these hormones cause activation of adenylate cyclase, which synthesizes cyclic AMP, which in turn activates protein kinase A. And do you happen to remember what the kinases do? There you go, the kinases phosphorylate a substrate, and in this case, protein kinase A phosphorylates the enzyme glycogen phosphorylase kinase, which activates it. Now, glycogen phosphorylase kinase, which is also a kinase, can go on to phosphorylate the enzyme glycogen phosphorylase, which also activates it. Now, the activated glycogen phosphorylase is then used to produce glucose from glycogen. Now, the role of glycogen phosphorylase is actually to break down glycogen into glucose via a process called glycogenolysis, which increases blood glucose levels to address the fact that you're in the unfed or fasting state. The big thing to remember here is that glucagon as well as epinephrine cause the enzyme glycogen phosphorylase kinase to become phosphorylated, which can then lead to breakdown of the glycogen reserves to increase blood glucose levels. Now, with all that said, what do you think happens in the fed or hyperglycemic state? Well, when blood sugar levels are high, insulin is secreted from pancreatic beta cells. And insulin here activates a receptor tyrosine kinase, causing dimerization, which sets off an intracellular signaling cascade, which results in the activation of two protein phosphatases. And do you happen to remember what phosphatases do? There you go, they dephosphorylate things. And in this case, they're going to dephosphorylate glycogen phosphorylase kinase as well as glycogen phosphorylase, as you can see here. Now this will result in both of these enzymes becoming inactive, and consequently, glycogenolysis does not occur. Now there's also a less high yield pathway that occurs in muscle, in which calcium as well as calmodulin activate glycogen phosphorylase kinase. Now this process coordinates glycogenolysis, as we just saw, but just within the muscle, and it's done to ensure that there's enough glucose present to make ATP for muscle function. Now if we were to put all that process together, it would end up looking like this. And if we were to take all that and look at the image from our book, we get this. Now sometimes this can get confusing if you dive right into the subject with the full picture. So make sure that you break it down and understand the pieces to help make an overwhelming figure like this one become more manageable. Now just some general rules to review before we finish. Glucagon as well as epinephrine result in the phosphorylation of most enzymes on step 1, whereas insulin actually results in the dephosphorylation of these enzymes. And once again, these phosphorylated enzymes ultimately lead to glycogen getting broken down into glucose for energy production. Well, alright, that's going to wrap up glycogen regulation. See you in the next video.